it's not always necessary to check every number to find the factors of a number. We wanted to go through every single number in that example just to show the questions that we ask and the way that we look at a problem when we're trying to find the factors. But to save yourself a little bit of time, you can simply list the multiplications that equal the number that you're looking for. So for example, we really just need to look at the ways that we know that we multiply together, the numbers we know that we multiply together to get the number 12. So for example, in this case, I've just simplified what we did before, and let's just take a look at these to see how we can do this a little bit more straightforward when we're looking for the factors of a number. So I have 1 times 12 equals 12, 2 times 6 equals 12, and we know that the only other combination of multiplying two whole numbers together to get 12 is 3 times 4. Another great reason to have all of our multiplication tables really well memorized. Now we can see though that by the time that we get here to our fourth on the list, our 4 times 3 equals 12, and then our fifth item on the list, 6 times 2 equals 12, and our sixth item here, we can see that really they're just repeats of these three above in opposite order. So these patterns are the same as these, except they're just in opposite order. So what we really want to focus in on then is just these three combinations here of the two numbers that we can multiply together to get 12. We've got three sets of those: 1, 12, 2, 6, and 3 and 4. So really what we have when we're looking for the factors of 12 is we really have 1 times 12 and its opposite, 12 times 1. And then we have 2 times 6 and its opposite, 6 times 2. And then we just have one more, which is 3 times 4, and its opposite, which is 4 times 3. So we would simply again list these numbers in order as the solution to our finding all the factors of 12. So we would list 1, 2, 3, 4, 6, and 12 as all the factors of 12 in a little bit simpler fashion. Let's look at a couple more examples of finding out whether a number is the factor of another number. So I have here a question asking me, is 7 a factor of 63? And then we'll also find out if 11 is a factor of 63. So we want to remember that if a number is the factor of another number, we know that that factor needs to fully divide the number. So if 7 is a factor of 63, it should fully divide 63 with no remainder. So let's look at what happens when we divide 63 by 7. So 7 times what number is equal to or less than 63? How close can I get to 63? Well, 7 times 9. And 7 times 9 equals 63. So when I subtract 63 from 63, I get 0, which tells me that I have a remainder of 0. And that tells me that 7 is a factor of 63 using the divisibility test. So I could also ask myself, what whole number times 7, or is there a whole number that I can multiply by 7 to get 63? And the answer to that is yes. I can multiply 7 times 9 to get 63. The divisibility of it is the same, but it's in reverse. So I can do 63 divided by 7 equals 9. So that tells me that yes, 7 is a factor of 63. There's a remainder of 0 when I divide 63 by 7. Let's look at this next one. What about when I divide 63 by 11? So if I have 63 divided by 11, then I ask myself, what number can I multiply, what whole number can I multiply by 11 to get closest to 63 as I can, but still equal to 63 or under? And the answer to that question is 5. And so I multiply, I place my 5 here, and I multiply 5 times 11 equals 55. And I subtract 63 minus 55 equals 8. Well, there are no more numbers for me to pull down here, and so I can see that the remainder is going to equal 8. So this one does have a remainder of 8, which tells me that 11 is not a factor of 63. No. Another way to look at this, or to test to see if you've done the problem correctly, is to stop and ask yourself, what whole numbers can I multiply by 11 to get close to or equal to 63? So I know, though, that when I multiply 11 times 5, I get 55, and when I multiply 11 times 6, I get 66, which is too high for my number of 63. So no, there are no whole numbers that I can multiply by 11 to equal 63, so 11 is not a factor of 63.